Cisco Embedded Event Manager, or EEM, is an automation engine built right into your iOS. No external tools or servers are needed. It watches for events and runs your commands or scripts. Today I'll show you EEM detecting instability in a primary WAN link which is running BGP and executing commands to smoothly shift traffic to the backup path automatically. Lastly, we will manually run an EEM script to fail back over to that primary link. Let's do a quick run through of the topology. We have the core switch connected to two edge WAN routers. ISP prod is the primary, ISP backup as the secondary, and the upstream router representing AWS. On the LAN between the edge routers and the core switch, we have iBGP. All three are on autonomous system 65001. Edge to AWS is eBGP. AWS advertises a test loopback 9.9.9.9 into autonomous system 65050. In normal state, the core routes traffic out the primary link, and AWS returns the traffic via the primary. All route manipulation is performed on the edge routers using route maps. That's the topology. Core to both edges iBGP, edges to AWS eBGP. An EEM policy is like an if-then statement. Event detectors are like the if. Basically, if we see these alerts in logs, the action section is the then part. If we see those logs, then execute these commands. So let's take a look at the configuration. First, we need to create the EEM policy. The command for this is event manager applet and then name the policy. We're going to name this one wan_degrade_1. This is going to be the event-driven policy we'll use to downgrade the primary link in BGP. And you can see we've entered the applet submode. So like we said previously, EEM is basically an if-then statement. So the if portion of this will be the event that EEM will be looking out for. So the command for the event detection is event syslog occurs 3 pattern. This basically says look out for this syslog message. If the alert shows up 3 times within 5 minutes, execute the actions in the policy. I'm just going to paste that syslog message that we wanted to look out for. As you can just see, it's the line protocol on interface gigabit 01 changed state to up. And at the end of that command, we will enter period 300 to set the time to 5 minutes. So again, this is just looking out for that syslog message. If it appears 3 times within 5 minutes, execute the commands that we are just about to enter. So that's the if. The then part is the commands that you wanted to execute if the event occurs. So I'm just going to copy and paste a couple of the commands here because I want to get through this quickly. So the commands will be action and then a sequence number for the action. As you can see here, I have 1.0, 1.5, 2.0. That's just to leave a little room if we want to enter in other commands at a later date. So you can see the first action is enable, just to get the privilege mode, configure terminal to get the global configuration mode. And the third action here is to enter the route map configuration mode. For the route map, we have assigned to the BGP neighborship with the core switch. 2 more commands. We will keep following the sequence number pattern, 2.5, 3.0, and so on. So the action here is to remove the local preference. We currently have 200 set on this route map to make it the more preferred route from the core switch, and to set the local preference to 50 to ensure that the core switch prefers the backup ISP. So the next command here, you can see we're going into the route map configuration mode. For the route map, we have assigned to the neighborship between the primary router and the AWS router. And we wanted to set the autonomous system prepend to 5 prepends, which will make the AWS router route traffic via the backup route. Next action is end, just to go back to privilege mode. And then the following 3 commands is to soft clear the BGP adjacencies, both on the core switch side and the AWS side. And our final command, action 6.5 syslog message, followed by a syslog message. This basically outputs a syslog message to your console when that EEM policy has been executed. Very useful when reviewing logs. It tells us that the primary WAN link has been degraded and the backup will be the preferred. And that's it. That's the event-driven EEM script created to downgrade the primary WAN link. Now I know there is a lot of BGP config there, but if that's not your thing or you're not familiar with BGP, don't worry about that. Just take a step back and realize that EEM is simply looking for an event to happen And if that event happens, then execute the commands we have listed in the EEM policy. EEM has many uses. Events it can watch out for can be any syslog message, a counter crossing a threshold, an interface going up or down, a BGP or OSPF neighbor changing state, an IP SLA track failing. The actions can be to run a sequence of CLI commands, adjust routing preferences, toggle features, quarantine a port, snapshot a config. It can even send a custom syslog or email telling you exactly what fixed the problem. My point is EEM is very versatile and has endless uses. It just so happened that I decided on the flapping interface leading to a BGP instability for this lab. The last thing I need to configure before we get into testing is the manual restore script. The real-world purpose for this is simple. Once the primary circuit is fixed, we want a single action that puts the traffic back onto the primary link cleanly without any impact. Let's just jump over onto the ISP prod router here. This script is very similar to the degrade script, so I'm just going to copy and paste all of the commands to save time. As you can see here, the one big difference with this script is on the second line, event none, which basically means this is not an event-driven script. This is a script that we can execute manually. This restore script does three things. First, it resets the policy on the primary edge. For the egress traffic, it sets the local preference back to the normal preferred value so that the core chooses the primary link. And for inbound, it removes the autonomous system prepend so that the provider prefers sending traffic back to us via the primary link. Second, it refreshes BGP so that the changes take effect immediately. It'll nudge the neighbor facing the provider and also the iBGP session towards the core. And third, it logs exactly what the script did so that we've got a history in syslog. So let's just do some pre-checks here. So I'm just going to jump over onto the core switch and I'm going to do a show IP BGP 9.9.9.9, which is the AWS IP address. We can see here we have two paths. One is via the backup router, which is 10.255.2.1. That's the loopback interface of the backup router. And 10.255.1.1, which is the primary router. And we can see here why this is the preferred route, and we can see why it's the preferred route. We can see a local preference of 200, which is being propagated from the primary router via a route map. And we'll just jump over onto the AWS router here and do a show IP BGP 172.16.10.0, which is a subnet where our jump server resides. And we can see here we have two paths again, via the backup router and via the primary router. We can see AWS is routing traffic back through the primary link as well. This is because we've added an autonomous system prepend on the backup router to ensure that the primary route is more preferred. Okay, let's start some testing here. I'm just going to go over to the jump server here, start a continuous ping to the AWS IP address. As you can see, the pings are successful. Now I'm just going to drop the gigabit 0/1 interface on the primary router. And as you can see, the pings start to drop. This is the service impacting BGP instability caused by the flapping interface we want to protect against with this EEM script. So let's just jump back over onto this primary router, and I'm just going to drop that WAN facing interface of the primary router 2 more times. And as you can see, we see that syslog message that we configured on that last step of the script. WAN degrade now, primary WAN BGP degrade applied, local preference 50, heavily prepended. And we'll just jump back over onto the core switch here to verify. We'll just check the BGP route for that AWS IP address. As you can see, it's routing through that ISP-Backup. And we can see why it's using that backup route. We can see the local preference is 50 on the primary route, which is being propagated from that route map on the primary router. And we'll jump over onto the AWS and check the BGP route for that jump server. And that's also returning traffic back through that ISP-Backup router. And we can see why the secondary route is more preferred now. We can see on route 1 those autonomous system prepends that we've added through that route map. So basically what happened was the script was looking out for that one particular syslog message, which was the gigabit 0/1 interface coming back up. That happened 3 times within 5 minutes. It then executed the script that we had configured, which moved traffic over onto the backup link and refreshed BGP. The last piece I want to cover is to execute the manual EEM script to smoothly move traffic back over to that backup link. Just a side note, this BGP manual script specifically can be very useful in situations where you want to fail over the traffic to a secondary link to allow you to perform an upgrade on the primary router or vice versa. Let's just jump over onto that primary router. And the command is simply going to be event manager run and the name of the manual script that we created previously. Press enter. And as you can see, we have that syslog message. Primary WAN BGP restore applied. Local preference 200, no prepend. Let's jump over to the core switch to verify. Again, we're going to check the BGP routing for the AWS IP address. And you can see we're routing over that primary router again, and that the local preference on that primary route is back to 200. Let's jump over onto the AWS side, and we're going to check the BGP route for the jump server AP. And we're seeing the return traffic coming through that primary link as well. If you found this useful, folks, please like and subscribe. Also, if you have any good EEM use cases you'd like to share, please comment in the video. I'll see you in the next one, folks.